Hello everyone, today we're going to talk about logarithms, but also the laws and basically the most that you need to know about logarithms. So, first of all, what you need to know is the difference between let's between logarithmic and exponential. So basically, exponential is like the normal. It's like the OG basically, and so this is the base, right? The base is the number that is basically getting timesed, by itself. Then the x, wait, I'll do it like this. No, yeah, bleh. The x is the, so there was an argument, well, basically the answer if I'm honest. But in general, no, this is the answer. Y is the answer. Okay, but basically, x is the number how much times this number is squared by itself. And then, y is the answer of whatever this is. So, yeah. So, you should understand that, let's say we have log to the power of 3, 4, wait, 81. We have to find a number that gives us how can I explain? Not exactly an answer, but basically a number that how much times does 3 has to times itself to give us 81. So 3 times 3 is 9. 3 times 3 is 9. Wait, please. And then these two times to give us 81. So the answer is 4. And yeah, let's say you have something like this. You just write down what the answer would be for this. And if you want to put it into logarithmic form, then the base, the answer, equals 3. So, and basically, let's say you have this type of question, right? You just have to move everything into this form, as we know that basically, yeah. And then you have to turn this number, to find out this number, you have to turn this number into 2 and kind of, again, think of how much numbers you need to make 32. The way you can do that is you can't do division, I'm pretty sure. Yeah, probably can't. Yeah, definitely can't. Wait, could we do this? Ooh, we actually could. So basically, on a calculator, what you're able to do is each time you're able to like change the number and see, so when do you get 2? And as we saw, the answer is 5. So x equals 5. So another thing to understand is that log 10, log 10 is equal to a normal, like without base. So if you don't see a base in a question, it's 10. It's always 10 unless that is already a base in a question. Also, a natural log. Pardon me, so natural log is log e x. E is an actual thing on a calculator, but this is equal to this. Like, it's also on a calculator, by the way. So, now let's say we have, okay, let's just put any, but it can be any number, so no, let's just put a number 2, 1, and the answer is 1. No, wait. And let's say this is also known equals 0. Let's say we have something like this, right? So we do know that, so the answer will be 1. No matter this number, the answer will be 1 because anything to the power of 0 is 1, apart from 0 itself. So this cannot be 0. And also, if the base and the argument, that's the word for argument, is the same, the answer is always 1. If they two are the same, it's always 1. Okay, now let's go on some laws. So the first law is log A equals AB. So if the bases are the same, you are able to just like times and plus like, let's say this is your question, you can write it like this. And as an example of that, let's say you have log 4 2 plus log 4 32. You're able to write log 4 60, well no, 64, because these two times each other. And so then we're able just to do our regular stuff where 4x equals 64. Well, that would be 3, because 4 times 4 times 4 is 64. So yeah. Now the second rule is log 4 2 plus log 4 32 equals log 4 6 4 equals, oh no, what? That was a question. Log A equals A over B. That equals to log A, take away log AB. So let's say we have something like this. We're able just to write log 2 equals 80 over 5. That answer is 16. And then log 2 16 is equal to 4. Now let's say we have something like this. What we're able to do, we're able to move that to the, like, at the start. So we have this left. And the way this may be useful is, let's say we have this, we're able to write log bless me. We're able to write this, and as we know, 8 times this would be, I mean, not exactly times. I mean, basically, yeah, it would be times, but yeah, no, that doesn't work. So, of course, you have a calculator to work it out, but I'm just trying to figure out how can you work without a calculator. Well, think of it like this. Think of it like, again, how much numbers do you need to make a 3? And then that's going to be 1 over 2. However, I don't understand why it became positive. Let me quickly check with ChatGPT. With the end result. I still don't understand why did the 2 become positive.
I'm not sure I follow. Do you mean when you divide two positives? Because if you do, a positive divided by a positive is positive. The sign doesn't flip. Does that match what you're looking at?
I don't understand why did 8 to the power of minus 1 over 3 equals like log in brackets 1 over 2. Like, why is the fraction positive?
Let me just check that. Right. It's not that the exponent becomes positive. It's that the negative exponent makes a reciprocal. So 8 to the minus 1/3 equals 1 over 8 to the 1/3. And 8 to the 1/3 is 2. So the value is 1/2. It's positive because reciprocals of positive numbers are still positive. The minus sign doesn't make it negative. It just flips the fraction.
Okay, I still don't understand. Still don't get. Think of it. Think of the negative exponent of negative number sign as completely different things. For example, it's a negative number, but it's not negative. It means 1/2. Aha. Does not make the number negative. It takes the reciprocal, flips the fraction, so. Work out the roots, so. Okay, basically, when we come to this result, like this part, we find out the reciprocal, I think that's the word, or whatever, how much numbers of 3 do you need to make 8? The answer is 2, so that's where we got this from. And that's the end for this example. Now let's talk about the change of base formula. So let's say we have log bx. We're able to make it into log ax, log a b. And what I mean, what I mean by this is the a's are tens, like they basically don't even need to put them. This is like most of the time people change it into not natural normal logs, but also we do use natural logs in this situation. An example can be log 8/5. That is like we can make it into this, even though I don't understand how and why, so I'm gonna ask ChatGPT. Hey, I'm like revising logarithms, as you understood. I don't understand how does change of the base formula work? Like, why does...
Sure. When you change the base of the logarithm, you're just rewriting it in a different base without changing its value. Say you have log base a of x. The change of base formula says that's equal to log base b of x divided by log base b of a. Any base b that you like. Usually we use base 10 or base e. It works because logs are exponents, and exponents can be expressed with division. So it's like using a translation dictionary, but for logarithm bases. Does that make sense?
I still don't understand. Explain with more easy examples and easy words.
Sure, just a sec. Okay, picture this. Imagine speaking English, but your friend speaks French. You both mean the same thing, you're just using different words. Logs work like that. If you want log base 2 of 8, that means what power of 2 gives 8? The answer is 3, because 2 to the 3 is 8. Now, using the change of base formula, you could do log 8 divided by log 2 instead, and your calculator still gives 3.
So,
Same meaning, different language. Does that feel any closer?
wait, so log base 2 and argument 8 is equal to log 8 divided by log 8?
Almost. The denominator isn't log 8, it's log of the base. So if the base is 2, it should be log 8 divided by log 2. That gives 3. If you put log 8...
So
yeah,
wait,
that would...
so basically we kind of forget about the base, and we how can I explain it? We basically use the two numbers. We only use the base and the argument. So the argument goes on the top, the base goes on the bottom.
Right. So if you start with log base 2 of 8 and want to change the base, you do log 8 divided by log 2. Same value, just written in a different base. It's like converting meters to feet. You're measuring the same length, but with a different unit.
If I had log base 5 argument 10, would that equal to log 10 divided by log 5?
Let me check. Yes, exactly. So if you have log base 5 of 10, that's log 10 divided by log 5. Just remember, top is the argument, bottom is the base.
Okay, guys, that's the lore behind it. Now, let's go through some questions. So, yes, there's no exactly what we have to do, but most of the time we just have to do the opposite of what the law tells us, like as if like the different version of this. So let's go. Log x3 take away log plus log y4 take away log c6, and then we put the numbers here. And this would be our final answer. So this is more confusing, however. Basically what the guy does in the video, he does like this as his next step. I don't understand why he was able to move. Okay, let's say he... Okay, no, I don't understand why he was able to move the X. Okay, let me write in more neat so ChatGPT can understand. confused. Explain. Okay, apparently the multiplication rule says that I'm able to move this. As if not exactly move, but like this is equal to it being the thing and being added, as we can see here. But I don't see why does that plus whole work if like x isn't the argument, x isn't the argument. That's a really confusing. Okay, so yes, actually is the part where I can look at the expression, the entire argument of the logarithm. Everything inside the brackets is the argument. Now think of it simpler. Theta is not just because the argument. Okay, basically, apparently does this work. I don't understand why, but yeah. Okay, after that, we move the thing here, and then, yeah, Okay, before getting the final answer, the guy had, like ChatGPT has one, ln x, take away 1 to n x is 1 over 2 ln x, and then okay, what he did was basically, wait, where did the C go? Wait, actually, though, where did the C go? Let's see. Okay, yeah. So yeah, this is the end result. I mean, it does seem very hard. It does, generally. So basically, this is like easy one. We know that this number, basically 4x equals 1 over 64. Think of a number that creates 64, 3, and then because it's a fraction negative, because negatives create fractions, so yeah. X equals 3. So find, giving your answer to three significant figures, the value of x for which. So basically we're able to transform to the logarithmic way. So 10, that equals x. Now whatever this equals to is basically this as, no, this iPad calculator is bad, so basically whatever you get as an answer, you put it to three significant figures. Express log 2 4 plus blah 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 as a single logarithm to base. Well, these two times lol, that was actually more easier than I expected. And so we have a log 2 to the power 64. Okay, no, that's not what the question is asking us to do. So express a log 2 as a single logarithm to base. Okay, what this question is asking us to do is basically, so this equals 2 because 2 plus 2 is 4. This is 4. And these two is 6. And we're asked basically to make a logarithm that will suit 6, like the answer of these two. So log 2 6 equals 6. So we need to, this is basically what we have. The reason that with having 6 as our thingy-majiggy is because, like, how can I explain? Basically, we're looking for the answer of these two, like the simplified version. So, and then we just do these two, like 2 to the power 6, so 64. However, I was right the first time because I just looked at my notes. You can't just times these two, get log 2 and 64. And the answer will be 6. So yeah, that's just the easier way. But if you need the marks, I guess if it's just, I don't know, yeah. Show you working, guys. So, last time we're gonna go the easy way. Basically, done like straight away, bro. Like we know that we're dividing them, so we're dividing these numbers. The answer is 27. So the answer is gonna be log 327, and then the answer is gonna be 3, yeah. So and then, mate, now you wanna solve stuff. Express as a single logarithm to base. Okay, this is a bit more harder. So, but at the same time, no. So we just move the thing here, and so 8 squared is so 62, 56, 56. So wait, is it? No, I'm fully wrong. 72, 64. Yes. And also this was also wrong even by taking away. So then what we get is log 2 to the power of 64. And the answer of this is going to be huge. Like, I don't want to work it out. I don't want to. So, yeah, just, yeah. And then, so first of all, what I would do is move the x here. And so after that, I would probably oh no, okay. I would leave the x there, move this to here, do log 5x squared divided by log x 5x3 equals 2. The logs can cancel, like they don't matter in this situation. And oh no, actually, so basically look, don't exactly cancel, so this is what we do. Log 5x x 3x equals 2. We know that 5 to the power of this, right? So we know this is 25. And so after that, because we want to leave like at least one, we can't have so much x's, you know? We're just going to divide everything by 3x. So x squared equals 75x. And so after this we have to use, what's it called? Basically the bracket thing. So we have to make it equal 0. So 5x equals 0. So we use the brackets and we're going to use a single bracket. Okay, so 5. So we have to either x equals 0 or x equals 75. And in logs, in this especially log, we can't have x equaling 0 because where was it? 3 is like powered, so 3 times x, and so like over here we have the answer 0, right? So look, yeah, even at the start with that, I didn't move it, so 3x over here, right? So that would equal 0, and we can't have the argument equaling 0, because that means that does not make sense. So that's all of it for today. Goodbye.